Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University. School of Agriculture, SOA. Diploma in Dairy Technology, DDT. BPVI 012 Dairy Equipment and Utilities. Block-1 Dairy Equipment and their Maintenance. Unit-4 Preventive Maintenance of Dairy Plants and Machineries. 4.0 Objectives. After reading this unit, we should be able to specify importance of preventive maintenance over breakdown maintenance. How an effective maintenance program is prepared. How to develop a lubrication schedule for a dairy plant. To keep SS equipment and its surface in good condition. Proper upkeep of all service pipelines. Proper upkeep of gaskets used in the dairy equipment. To keep dairy plants surrounding attractive and clean. 4.1 Introduction. In the Unit 3, we have learned various equipment required for the manufacture of milk products. An attempt was made to enrich with the operation of different equipment involved in the processing of most common milk products. Yet some special milk products could not be covered. However, the exposure given will give enough background knowledge to understand other equipment. In this unit, we will learn as to how to prolong life of equipment with proper planning. As we know, the milk processing equipment are expensive, hence need greater care to give best results. One way to maintain the equipment is to run as long as it works and repair it when it stops working. It is called breakdown maintenance. A scientific way of maintenance would be to do preventive maintenance, PM. As a thumb rule, 6 to 12% of machine cost will be required for proper maintenance of machine every year. In order to carry out PM program, planning is done. We will learn different records and forms used to follow up schedules. These will act as guidelines for plant operators. These records also indicate the preparations for future planning. What are the needs of spares, oils and greases, etc., can be easily decided. Oiling and greasing is lifeline for individual machine. Every equipment has been recommended a lubrication schedule for every dairy plant, daily, weekly, monthly and quarterly. Planning can be done. A lubrication route for the technician can be suggested and appropriate checks planned. Dairy equipment are required to work under unfavorable conditions of high moisture, chemical environment, and temperature and pressure stresses. These conditions do affect the life of material with which the equipment is fabricated. Also, the aesthetic look of equipment is need of such industry. It gives psychological impression to workers and the public for the conditions prevailing within the plant. All the processing equipment need water, steam, refrigeration, air and electricity. These are supplied through appropriate pipelines and cables. Well-maintained service lines not only reduce the losses but also offer good look. Injuries and accidents can also be prevented with little care. Most of equipment are provided with components made of rubbers. These are unavoidable, yet designed with utmost care to maintain quality of product. The upkeep of these components are a must. Readers will learn as to how to take care of these parts and prolong their life. Finally, even if each and every equipment is in order, the plant surrounding landscape sanitation needs utmost care. Building maintenance is the first impression given to the visitors and public who pass by this unit. All walls, seepage, odor, well trimmed grass and shrubs, well-parked vehicles, etc., offer reputation of the dairy plant. As a first impression, a summary of civil maintenance will be discussed. 4.2 Principles of Preventive Maintenance. Dairy equipment are expensive due to their specialized construction. Some of these are sophisticated and imported, hence, needs proper attention. In general, there is less appreciation to the maintenance activity, preventive maintenance, PM. Its importance is realized at the time of breakdown. A PM program is a procedure designed to increase plant productivity, decrease maintenance, reduce operating cost, and to increase life of the equipment. It involves routine external inspection. It means external viewing in terms of noise, vibration, heating, or any sign of malfunctioning. This is noted and corrected, if any. Periodic internal checkup. It is done when the equipment is shut down at the end of operation. This is not a major repair action. One has to decide the duration after which this checkup is done. In this, adjustment of control instruments, replacement of lubricants, surface touch-ups, etc., are carried out. During this checkup, looking at the condition of equipment can make an idea on the possible major overhaul. Major repair, overhaul. Major repair is then planned preferably in the season when the equipment is not in use. Most of the major repairs are carried out during summer months when the milk handling capacity is less. For refrigeration section, the repairs are planned in winter months. Prior to shutdown, selection, procurement and stocking of spares must be ensured. IV. Evaluation of equipment performance. A good engineering function is to carry out routine evaluation of each and every equipment. Due to normal operation, the efficiency of equipment reduces. This in turn affects the productivity. There are set procedures to calibrate and measure the flow capacities, heat transfer efficiency, product output, utilities consumption, etc. Again, the frequency of such evaluation is a matter of experience and planning. The awareness on the part of management is also an important factor. Versus record keeping is a part of PM procedure. We must maintain the work and breakdown record of the individual equipment. This will also indicate the repairs carried out. These records help in subsequent planning. These records are called logbooks. Proper proforma is developed to indicate exact duration of running, various inputs utilized, efficiency and check parameters, records of repair and nature of complaint and the person who carried out the operation and repair. Periodic verification is carried out by superiors as a check and feedback. If above procedures are adopted, the cost of maintenance will be less, equipment efficiency will improve, plant productivity will increase, accident possibilities are avoided, and finally the life of expensive equipment is extended. 4.3 Development of Plant Maintenance Program. The very first step for development of PM program is to record basic equipment data with appropriate classification. Recording should be simple but reliable. Usually, card file system known to engineers could be adopted. This information can be required anytime, hence, be readily available and preserved. Administrative information. This should include equipment's name, its supplier, sanction order, date of purchase, date of commissioning, its cost, etc. This will be needed at later date. Technical details. Information such as serial no, model, style, capacity, speed, rating or size. Recommendations of manufacturers for installation, operation, lubrication type and quantity, frequency of lubrication replacement and precautions, if any. Specific details. Mechanical, electrical and utilities required such as regular water, soft water, refrigerant, steam, fuel, electricity, compressed air, and quantity of effluent discharge, etc. It may also record the working pressure and temperatures, voltage, insulation, and the inventory number given while entering in record to identify it. IV. Identification of critical points. Now decide the list of specific points of each equipment to be inspected and point area which should not be inspected. Obviously the point which wears out fast or gets eroded, damages, needs regular inspection. The parts dangerous to the worker or likely to stop the plant operation should be avoided. Natural question comes in mind is as to what to inspect. The answer will be from the recommendations of equipment manufacturer's manual. Then prepare a checklist in the order of priority. The idea is to give a written guideline to the person who will carry out inspection. This checklist helps to recall and assure proper execution instead of leaving on the memory of the individual. Versus frequency of checkup, inspection. It is decided based on the condition of equipment. Older equipment needs frequent inspection as compared to newer ones. Similarly, there may be safety recommendations, hence, frequency of inspection will be increased. The extent of equipment used and the type of wear will also play role in deciding the frequency. Equipment performance. Finally, we should keep on evaluating the performance of equipment. Normally, equipment performance will decrease with time. It will then increase cost of production. The report, remark of operator in the logbook will act as a feedback. Hence these comments be seen and compared with the manufacturer's recommendations. If it is felt that the performance in term of flow, capacity, quality, utility consumption etc. are above normal, then actions are required. Planning is then made as to when to shut down the equipment, what spare parts are needed and made available. It is also assessed as to whether skill is available within the maintenance group or help from outside will be needed. How much financial burden will be on the dairy and if the money is available. These are some of the crucial points of judgment of efficient PM program. 4.4 Guidelines for effective lubrication. Program. A guideline for proper lubrication of the equipment for any dairy plant can be prepared from the recommendations made in manuals of individual equipment. Manufacture of equipment does indicate the type, quantity and lubricant required. From various lubricants recommended, a common list of lubricants could be prepared. To minimize diversified needs, mark the points of lubrication on equipment and in the record book. Then, plan a schedule en route for technician. Evaluate the suitability of lubricant application method and change if required. Normally the cost of lubricants ranges from 3 to 10% of the machine cost. With the information gathered, a route map could be prepared. This map covers all machines that can be lubricated in one shift or a day. This way daily, weekly, monthly, quarterly, semi-annual and annual lubrication chart are prepared. A supervisor or engineer needs to monitor these charts for effective lubrication. Program. 4.5 Care and cleaning of SS surface. Stainless steel, SS, is expensive metal and therefore needs care. The frequency and the extent of cleaning depend on the extent of usage and the condition. I. Cleaning of soft deposits. Ordinary deposits like dirt, grease are cleaned with mild detergent, soap, and washed and dried. E. Hard deposit. However, hard deposits need different treatments such as rubbing, buffing with polishing powder and SS brushes. Soft cloth or pads are used to shine the surface. Plastic sponge or fibrous brushes are also safe to use. Avoid iron wire brush, steel brush, and should never be used for rubbing. This brush will leave iron particles on SS surface, which will cause rust. E. Care with sanitizers. If chlorides, bromides, iodides-based chemicals used under acidic condition for long, there are greater chances of corrosion, hence should be washed properly. IV. Care with salt solutions. These leave dirty spots on drying, hence should be washed after use. No paint or any coating is done on SS surface. Sometimes rust-like appearance may occur, which is due to some iron chip or part adhered on SS surface for cleaning. 5 to 15% caustic soda, hot or cold, is commonly used. Sometimes 0.1 to 2.0% hot. Solutions of sodium metasilicate, trisodium hexametaphosphate, and tetrasodium pyrophosphate, sodium tripolyphosphate are used as excellent removers. Organic solvents are sometimes used to remove oil, grease, paints, or hard deposits. These organic solvents are ether, alcohol, kerosene, gasoline, etc. Highly adherent ink, paint, etc. can be removed by butyl acetate. For very heavy water deposits, 15 to 20% nitric acid can be used with caution. Acid cleaning is followed by proper washing to remove any trace of acid. 4.6 Care of pipes and fittings. You will find that a milk processing plant is full of various types of pipes. Various utilities like milk, water, air, steam, chilled water, hot water, refrigerant, electricity, etc. are transported, conveyed through these pipes. To regulate and control flow, different valves and fittings are provided within this piping network. This network must work without the loss of product, energy, corrosion, noise, vibration, leakage, etc. They should also offer ease in working and accident-free operation. I. Care of pipelines. Pipeline once laid, very little can be done. Only protection from moisture, oxygen, and acidic environment should be done. If pipe is embedded in soil, asphalt covering will protect it. Overhead pipes are kept dry and painted. Inside pipe corrosion can only be minimized if entry of oxygen could be reduced. Even dissolved oxygen in water affects it. E. Care during installation of pipes. Water hammering is due to movement of water with jerk. This is caused by sudden closure of opening of fluid and accumulation of residual fluid inside pipe. This obstructs the normal flow. Hence, pipelines are given proper slope and drainage. Point to avoid any accumulation. Pipe supports are adjusted to give proper slope to the pipes. Maintenance of pipes joints. Some pipes carry hot and cold fluid like steam and chilled water. The temperature change causes thermal expansion of metallic pipes. These pipes have provision to absorb expansion. Check for roller support and expansion joint, loops of pipes. Similarly, the leakages from pipe joint should never be allowed to continue. As soon as a leak is noticed, it should be plugged by replacing the gasket or correcting the alignment. IV. Care with pipe insulation. You will note that certain pipes have insulation covered with aluminum cover. Cladding. Pipelines carry hot or cold fluid. Steam line is insulated with glass wool, reinforced with chicken wire mesh and clad for long life. Similarly, children. Refrigerant lines are covered with thermocol insulation and clad. We must ensure proper insulation if it is found removed or not in good condition. Versus care of valves and fittings. These are integral part of pipeline system and of different types and shapes. Valves may develop leakage either from gland of the stem or valve seat may not close the valve fully. If gland is leaky, it is repacked and lightened. The stem threads of the valve should also be lubricated if the gland is dry. The valve seat is also cleaned and grounded if seating is not proper. In most of the cases, valves are replaced. Fittings, i.e., the elbow, bends, unions, flanges, sockets, T, cross, plug, etc. help in change of direction or connection to the equipments. Usually for any defect, these are replaced. 4.7 Maintenance of rubber and gaskets. Dairy equipment have number of joints and connections requiring leak-proof arrangement. Stationary equipment like plate-type heat exchanger, chiller or pasteurizer will have gaskets between individual plates. Moving or revolving equipment such as pump shaft or cream separator will require shaft seals, O-rings, etc. Characteristics of rubber and gaskets. All of these must be chemical resistant, as acid and alkali are used as detergents. These should be resilient to offer leak-proof joints. These are of varied shapes and sizes to suit particular location or purpose for which these are used. They are required to work under high temperature and preserves, yet should not get damaged or contaminate the milk and milk products. It is, therefore, important that the rubber and gaskets should be of non-toxic material, should be heat resistant, durable and should not get damaged with the chemicals used for cleaning. The material of rubbers, gaskets is discussed in the Unit 1. Care with gaskets and seals. These have comparatively shorter life, hence require utmost care. Since these are between joints or moving parts, over-tightening be avoided. You will notice leakage from pasteurizer at the start. Slowly the leakage will reduce and may stop without tightening the plates. This is due to heat expansion taking place. If you notice leakage even after enough warming up, then plates may be tightened. Over-tightening may permanently deform the gaskets. This will result in reduced thickness, gap, between the plates. Ultimately, this will affect the capacity of pasteurizer. Similarly, packing, O-ring in the union or joint should not be over-tightened. Usually a good joint should be leak-proof. This could be made leak-proof by hand tightening in. Does not require a spanner. Gaskets between pipe joints get damaged while reassembling. This is due to poor alignment of pipelines. As discussed in the previous chapter, the alignment must be corrected before tightening the joint. Pump seals. These also need good care. Seals are expensive and require correct assembling. The carbon seal face rubs the stationary wall of the pump body, hence, the surface should be well polished and clean. While fixing the new gasket, old gasket and its particles should be removed with either a gasket remover or cleaned with the help of a sandpaper. 4.8 Dairy building sanitation. A clean and well-maintained dairy building and its surrounding promotes cleanliness habit amongst labor force and quality of its products. It automatically gives positive publicity and awareness to public for quality of products. A clean surrounding gives a sense of pride. A regular inspection by a team of decision makers helps in identifying the areas that need attention. It includes plant surrounding, landscape, condition of building, equipment and machinery. Storage and warehousing, lighting. Services, drains, hygiene of employees, toilets, dressing rooms, canteen, drinking. Water zone, insects, rodent infestation etc. There are some indicators for clean and efficient dairy plant. These will reflect how good a plant is. Toilets and workers' amenity rooms are the first in the list. A neat and clean, well-ventilated, odorless toilets indicate the level of sanitary practices in the plant. Workers' dressing room be well lighted and should have enough space. Floors should be clean, shiny and throwing of trash behind doors or under the benches should be discouraged. Building premises should not harbor broken or discarded equipment, furniture. Trash and rubbish should not be thrown around that creates breeding ground for insects and rodents. Wall, floor and ceiling should remain clean, dry and well painted. In the dairy, light color paints are used for walls and ceiling to reflect dirt or deposit for immediate attention. There should be proper lighting and water or dirt should not be accumulated at any point on the floor. Insects and flies should be adequately prevented entering in the milk processing zone. Doors and windows should have wire mesh covers and even air curtains should be provided. These air curtains produce thin layer of high-speed air to prevent entry of flies. Mold control is also important since the dairy plant uses lot of water, hence more humidity causing moist environment. This is conducive to mold growth. To prevent this, all exposed surfaces should be kept dry. These are brushed, cleaned with soft detergent and a spray of 5000 ppm of sodium hypochlorite is done. This destroys the mold spores. Further spray of quaternary ammonium compound is done to inhibit mold growth. This should be repeated every week. Insect and rodent control in general should be practiced. There should be no accumulation of dirt, filth inside as well as outside the Garbage and Wastes Act. As breeding place of insects, good insecticide spray can be performed around the drains of dairy plant. For outdoor spray, methoxychlor, malathion or permitted insecticide with recommended strength could be used. All equipment is covered to avoid entry of these insects and pests. Rat-proof building designs are made. Building openings are plugged. Height of the floor and steps are made such that rats cannot jump or climb. If at all, the rats find entry, they should be eliminated. 4.9 Summary. The preventive maintenance program is normally not well understood by the plant management. The simple reason is that people are tuned to manage the show. After the breakdown, the advanced planning necessitates preparations for enough spare parts and systematic maintenance. In the long run, the preventive maintenance program improves the quality, as there are less number of breakdowns. It also reduces the manufacturing cost, hence, improves the productivity. Often the management is interested to know how much will a dairy plant cost and then followed by how long will it take to pay for itself? The professionals engaged in maintenance program may find these questions embarrassing, but the advance planning pays subsequently. The main objective of preventive maintenance is to make timely repair and prevent unscheduled interruptions. This also helps in eliminating personnel hazards and extends the useful life of equipment. In this unit, procedures as to how preventive maintenance are done have been described in detail. The Intelligent Maintenance Group will prepare a basic equipment data, which gives complete history of the newly acquired equipment, which will subsequently be useful at the time of disposal, replacement of the equipment. Each manufacturer also gives the recommendations of critical points on each machine, which may form a proper schedule for maintenance. With regard to procedure, the external inspection, which is conducted almost daily, gives the first-hand knowledge of the condition of equipment, dairy plant and its surroundings. Sometimes, a group of supervisory, managerial staff takes a round and note down general aspects of the equipment, such as noise of equipment, rise in temperature, smoke or other emissions, operating parameters indicated through various gauges provided on equipment, lubricants level through indicators, general upkeep, moisture condensation, filth, etc. Any abnormality is immediately corrected and this will give way for internal inspection. For internal inspection, equipment has to be shut down, sometimes dismantled, and, therefore, this aspect is done with appropriate planning. Internal inspection depends as to whether we have a standby arrangement or there is need to shut down the plant. Often a total shutdown is planned for lean period. A periodic re-evaluation of maintenance program is done through assessment of plant performance. This assessment also helps in taking decision as to whether the equipment involves high maintenance cost or requires excessive downtime. The repetitive failure suggests the plan for replacement of the equipment. It's easy to develop a lubrication schedule program with the help of equipment data sheet. Individual equipment manufacturer describes the type of lubricant and the frequency of its replacement. With the help of equipment inventory, a total lubrication route map with schedule of lubrication daily, weekly, monthly, quarterly, annually is prepared and a complete lubrication year chart can easily be prepared. Each oiler, lubricator performs his assigned tasks based on the recommendations from this very schedule. For care and cleaning of stainless steel surfaces, following practice should be implemented. Use only soft fiber brush or pads to mop the surface. Iron, steel brushes should be avoided. Salt and minerals of water gets deposited on the surface, hence, some water conditioner, softener should be used. No metal part or weld spatter should remain adhered on the SS surface. It initiates the corrosion. Whenever acid cleaners are used, these should be neutralized with alkaline solution, followed by hot water rinse. Avoid chloride solution in higher strength. Equipment must be dried after water wash. There should be no stress on the equipment. Thermal, mechanical stresses enhance corrosion. For any repair such as welding, same grade SS electrode should be used. Maintenance of pipes and fittings is a big challenge. As soon one enters a dairy plant, the quality of maintenance can be judged by the upkeep of pipes, valves, insulation, supports, etc. All moving parts of valves such as stem threads, sleeve, lever, should be regularly lubricated. Dry stems lead leakage. Similarly, stuffing boxes develop leak, hence, the packing should be replaced. Valve seat does not close the valve due to deposit. The seat is cleaned and reset. Most of the pipe joint get leakage, the gaskets should be replaced and pipe alignment is also corrected. Pipe insulation and aluminum cladding also gets damaged in due course. Regular repair, renovation be carried out to avoid heat loss and ugly appearance. Steam traps of steam lines often indicate leakage. To avoid wastage of steam, the trap nozzle, seat should be reset or cleaned. Rubber packing and gaskets are the most vulnerable parts of the equipments. Every equipment uses them in one form or the others. Pasteurizer plates, manhole gaskets, special parts such as pump seals, separators, homogenizers, fillers, O-rings in flanges, unions are made from non-toxic rubbers. These get damaged due to wrong assembling of the equipment. Due care must be given to the alignment. Proper tightening pressures, recommended temperatures and pressures. The maintenance issues pertaining to individual equipment have been discussed, along with their descriptions, hence, no separate discussion is required. The general upkeep and maintenance of dairy building and its surroundings is equally important. The first impression of any visitor is formed only by outside appearance. A routine surveillance visit by decision makers should be made regularly to see for general cleaning. There should not be waste scattered around, general filth, water accumulation, dampness patches on walls, ceiling or floors, and all lights and electrical gadgets be in order. There should be no water seepage or leakage from pipes or taps. Landscape around dairy is well maintained. Hedges, shrubs, lawns, pots etc. be well trimmed, sized, painted. All connection roads, streets or subways are made clean, properly marked. Doors, windows and other entry points should be provided with fly-proof mesh, window pans, glasses in good condition. Rodents and insects control through building design and subsequent provisions be ensured. Regular spray of pesticide and fungicide is carried out. Thank you for watching. We will see you in the next video with the next chapter.